In this problem, again, I'm given a complicated looking trigonometrical expression, and I'm going to try to simplify this down to just a single trig expression with just one theta in the problem. When there are several different approaches to do this, you want to go back and refer to some of the trig identities and definitions that we know and see if there's any substitutions and simplifications along with some algebra approaches. Like I said, there are several different ways to approach this. You could write all of your values in terms of sines and cosines. You could do some division of fractions since there's no plus in the denominator here. Or one of the things that I recognized right off the bat, because I kind of have identities on my brain, is the fact that 1 plus cotangent squared of theta has an equivalency based on one of our versions of the Pythagorean identity. If you remember, 1 plus the cotangent squared of theta is the same as the cosecant squared of theta. So I can use that version of the Pythagorean identity to say that cosecant squared of theta is on the top and cotangent squared of theta is on the bottom. So now what I've done is I now have no pluses anymore. I have no addition or subtraction in the problem, so it's already looking a lot nicer for me. At this point, one of the nice things that I can do now is to go ahead and rewrite this in terms of sines and cosines. Maybe some things will cancel out. The cosecant is equal to 1 divided by the sine. It's the reciprocal of the sine. So the cosecant squared of theta is going to be 1 over the sine squared of theta. So that can be on the top of my new fraction. The cotangent of theta can be written as the cosine of theta over the sine of theta. And so the cotangent squared can be written as the cosine squared of theta over the sine squared of theta. Cool. So now I just have a complex fraction. No pluses or minuses, nothing weird at all. Everything's a single fraction on the top and the bottom. So go ahead and think of it, this is dividing fractions. So I can multiply by the reciprocal of the bottom. So I have my first fraction, 1 over sine squared of theta. Then I'm going to times it by the reciprocal of the bottom fraction, which is sine squared of theta over cosine squared of theta. Nice thing that happens here, notice the sine squareds cancel on the top and the bottom, so they're completely out of the picture. And I just am left with 1 divided by the cosine squared of theta. In this particular case, we want to try to simplify this down to just a single trig function if possible. And 1 over the cosine is the same as the secant. So 1 over the cosine squared is the same as the secant squared of theta, which would be the best answer for this particular problem in its most simplified form.